Alright, we're going to have a quick little blitz review of some of the word problems that we've done with exponential growth and decay. First example I've got is a TV that you buy for $6,000, one of your new OLED TVs. It depreciates at 18% per year. We're going to find the value of this TV after 4 years. So, if we look at this guy, remember we have our beginning amount multiplied by our parentheses. Inside our parentheses, we're going to have 1 minus the rate of 0.18. 18%, remember, as a decimal is 0.18. And we're going to raise it to the t, the time power. And that's going to give us our amount that our TV is worth. If we take out our calculator and type this in, 1 minus 0.18 is going to be 0.82. And we raise that to the 4th power in our calculator. You can see over here, let's see if I can get it to focus, not too great, $2,712.73 is what our computer is, or TV, excuse me, is worth after 4 years. If we have a bank deposit of $1,000 and we have 2% interest, 6 years, we take our beginning amount of $1,000 deposit, 2% interest that is added is going to be 1 plus the rate, 1.02 is what that simplifies to. And we raise that to the t power for our time. In this case, we're going to look at 6 years. 6 years is what we're going to plug in there for our time. And when we do that, we have $1,126.16. Not bad. Again, remember, we didn't do anything really to earn that money. I just put it in the bank and let it sit there. Now, the rest of this video will be for my honors class, so you CP guys, if you want to hang on and watch this, you'll see some stuff that we're going to be doing pretty soon here, but the honors class has already done this. Honors class, we looked at things that were compounded at different rates. Instead of just once a year like we did with these, we looked at things that are compounded monthly or continuously. Remember, this formula slightly changes when you're looking at this. We had A for amount instead of Y, but that doesn't really change anything. That's still just the final amount. You still have your beginning amount out in front, and you are going to still have 0.02 for your rate. But instead of just adding the 0.02 like we did here, because it's once a year, you have 12 times per year for compounded monthly. You would take that 0.02 and you would actually divide it over those 12 times. So you're going to split that interest rate up over 12 times per year. Also, for your time out here, you're not just going to have your time up here, because it's not just going to be 6 times like we had 6 years. It's 12 times per year, so you'd have to have 6 times 12. So basically you have this formula has this extra little part here of 1 plus r over n and n times t on the outside, where the n is the amount of times per year that you're adding it. So you would actually have to raise this to the 72nd power, because it's 12 times a year for 6 years. And when you do that in the calculator, you can see it's not much difference. $1,127.38. Not much difference between those two, because we are looking at a pretty low percentage, low deposit. The last one that we looked at was called continuously compounding interest, and this I called the PERT formula. And the reason it's called the PERT formula is because of this little natural base E. Remember, this base E is 2.7182818284559. It's a special number, kind of like pi. So you take your beginning amount of $1,000 and then you multiply it by E, which is that special number, it's on the calculator, raised to the r times t power, or 0.02 times 6 in this case for our 6 years. And you multiply that out, and it's going to give you something that's just slightly above the other one, $1,127.50. So $1,127.50. So you can see the more times you add the interest per year, the more it goes up. This is why we talked about how credit cards can be a bad thing. And remember, I told you from personal experience, I've learned this. 12 times per year, that's going to be kind of like what a lot of credit cards do. They're adding that interest monthly to your account. Sometimes even more than that, sometimes daily.